Hello, welcome to this behind-the-scenes video series which documents the design process of a Eurorack module. This is the module itself in question, the tràigh transistor ladder low-pass filter, which I originally designed as the second module that I launched as Instruō back in 2016. So this is the original here, but I revisited recently for this project. So I'm actually joined on camera during the bulk of this project by David, he helps me run things behind the scenes here at Instruō. We spent a Saturday in the workshop just working through the schematic capture process. Ended up being somewhere between a sort of circuit design tutorial and some sort of video podcast episode of us just generally talking nonsense. And yeah, hope you enjoy. This is a B100. Oh, we could do the same trick here of making it a audio taper. So this is the output stage, which is actually just an attenuator. So I've got the output gain stage amplifying by almost 50%. So it's 56k into 100k. So that's a ratio of 56 up to 100 as a gain factor. So this just attenuates down. So I guess if that's in the middle position, that's unity gain going through. Just why a lot of the time when I'm patching with the tràigh, I try and just like leave that up full as the default, and then just use it as a master attenuator if I need it as a pre-gain stage, like before wherever else it's going.
You leave it up because what? Sorry.
I leave it up because it's not. If you're pulling it down, you're just attenuating, so you're just losing magnitude of the signal, which if it's too quiet later on, that's poor gain staging. It's a crude design. I mean, like ideally this would have been an actual amplification stage that integrated somewhere, but that would be a different circuit. It would be adding elements of like VCA to it. So this will be B100K. I'll do the same audio tapering trick. Let's move these over. There we go. And then that's our last op amp, which is already here. There we go. This will be 50k, 56k. Actually, what I'm going to add is a what value? Let's go 100 pico, because 100 pico already exists there as a basic filter cap. I'll put a very small capacitance capacitor in the feedback path, and that acts as an RC, a low pass filter, but with a very high cutoff. So it's just in case there's any artifacts from the circuitry where, like op amps, if they're mispowered or stuff, they can ring, they can have oscillations or resonances, so that will help. Just tidy that up a little bit, and then that's our 1K output impedance. Oh, footprint do not place. Oh crap, is that what I did? That's why they didn't update to do not place. I put do not place into the completely wrong field. Silly me. Okay, so these are resistors. That's what I want, 0402. So I just need to go through and check any of these there. That's what I did. That was stupid. That would have completely broken the footprint translation when we get to doing the board. The fun mistakes that can happen with KiCad. There's just these top two, isn't it? Yeah, that's fine. Okay, hopefully there's no other issues. And then an output jack. Oh. Y. No. X. Cool. There is our filter.
Sweet.
So flip-flop, that's the new bit of the circuitry.
Flip-flop.
Flip-flop. And I have a plan for this.
Does this exist in any of your current circuits? Is this what you use in the CSL?
CSL, anything that's a
Square.
octave, yeah, a sub-square, it's a flip-flop. So where can I copy this from? Which will just be quicker than drawing it from memory. TSL. Or TSL or CSL. I guess depending on when I get around to actually editing this, it could be months, or I could just blur this out as a fun exercise. What schematic will it be in? It will be in the main schematic. Sideboard. Here we go. Here is unnamed project. Oh, it's named. Whoopsie.
Redacted.
Redacted. So let's just use this as reference. So it's a 4013.
And you can beep whenever we say the name of the...
Yep.
So you can say things like...
Project B.
Yeah, well, I was thinking more like shell off.
Ah, yeah. That's something I hadn't thought about. Do I power this from plus or minus 12, or do I add a regulator? Regulator adds cost, but I might need to, there would be more circuitry to account for it, because like the output square waves, if I power it from ground and plus 12, is going to be a full 0 to 12 unipolar positive square wave, which is not ideal. 0 to 5 is a bit better. 0 to 5 is what I tested with. It was in the...
Just because it's such a high output?
Yeah. Let's go 5 volts. That way, actually, that's a good way to do it anyway, because that way its power is further isolated from the 12 volts, because it's regulated to the 12 to the flip-flop, and that I can try and keep it far away from the actual transistor circuitry to try and minimize any noise, because square wave signals are loud signals. So let's go 5 volts and let's power it from LDK could work. That's more current than it needs. Analog. What's the other regulator that I use? Something NXP, I think, is the part. NX. No, it's where have I used it? Cease v2's got it on.
MIC?
MIC. I feel like there's an X in it somewhere. LX something maybe. No. X. NXT? No.
LMX 1084?
LMX. No. I maybe don't have it in the library. Let me find CSV2. I did that. That was still an eagle, so that will be here. Cease. ADSR analog. Cease retrigg new repo. Here we are. Hardware. Let's open this. So that is LDK ZXT. There's a Z and an X. Oh, interesting. So I don't have that. I don't have that in KiCad apparently. Let's do a quick search of this. This will be plenty for it. It's like it's an LDO, low dropout regulator. But it's low current. Linear voltage regulator. It's only 15 milliamp output, but that'll be plenty for powering just a single dual flip flop. Oh no, it's 89 milliamps. That's what it is. Yeah. But I've used this on a few things where it's just powering CMOS stuff. Like that's the regulator. It's on the Cease 2 for powering the logic stuff.
Right.
Here's I mean, it's just that footprint. So can I get away with just using, instead of like adding the full thing, because I've already got that footprint. That's the same as that single transistor.
Just substitute the values.
Yeah, so if I just add in semiconductors, what's a regulator's got 3 pins? I guess 4040 does, so it's 1, 2, 3. It's the wrong schematic symbol though. It's I'm already breaking my rules by not just adding a part. Should I just add a part? I'll just add a part. Try again. Get status.
He was wagging his tail a minute ago as well.
Good, we got that on camera. He doesn't mind, he's in a cone.
No wonder he's so tired all the time.
Never gets a good night's sleep. Adding flip-flop. Push. Okay, so that is saved and updated and stuff. Let's open the library again. Where are we? Lib. Project. And I just need to add the schematic symbol because I've already got the SOT 23 part in. So let's do there anything that I can copy from? I'll just draw it. Okay, let's draw a new schematic from scratch. New symbol, and this is that. Oh, grumble, grumble. Is that what I want? Yeah. I think this is how I do this. Actually, what I could do is copy the form factor from a previous one. That way, if it's a case of like chopping and changing between an LDK 320, the box will be the same size. Let's see if this works. NXT. There we go. Whoop. Okay, so there's no enable pin, there's no adjust pin, there's just pin 1, 2, 3.
What's this U all about? What's this U all about?
That's the designator for it. So it's an IC. I could check what I've put down as reference for other regulators. It's U as well. It means if you add more of them, it would be like U2, U3, U4 as identifier of parts.
Right.
I think U is typically used for integrated circuits versus R1, R2, R3 for resistors.
Mm-hmm. U for integrated. Unified?
I don't know. What's pin 1, 2, and 3? Oh, it'll show me on this. 3D view. Okay, so there's pin 3 is in. Pin 3, and that's a power input pin. Ground is ground, which is 1. Power. Do we refer to that as an input? I think we refer to that as an input for ground, I'm guessing. And V out is pin 2, which is power output, yeah. Okay, 3 is V in, 1 is ground, 2 is V out. And this is, the value is that. Okay, footprint is our SOT 23, which is in here we are. So that in reference to this is this correct? Pin 1, 2, 3. 1 is ground, 2 is out, 3 is in, yeah. That data sheet is this guy, and description is linear voltage regulator, blah 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 blah. Keywords, LDO, 5 volts, regulator. That's fine. Let's try that.
It seems like when they were choosing designators, they started off making them logical and then ran out of letters, basically, and just started assigning them to other things. Like resistors R, capacitors C, diodes D, but then transistors Q.
Yeah, there are some commonalities that I've seen used, but some of them are just all over the place. Okay, that's done. That's added to the main project, so I need to save that.
push that to the main one. So we are in lib status. That's the new one there. Add dot git commit. It's sure, that's there. Git push. Go back, cd try again. Lib git pull. What? What have I done? Oh, cd lib. Now git pull. There we go. Okay, so that's there. We should be able to go back to our project. Oh, that's a board file. Schematic file. Here we go. Okay, let's add regulator. Yay. That's good. If I do that, it's got that part attached. Let's ground this. Let's check the datasheet for what the bypass capacitor situations recommended as. So 1 UF input, 10 UF output. 1 UF comes quite neatly in 0603, so let's go there. It's 12.6, cool. Let's copy that power flag there for 5 volts. Done.
Does the one on the left need changed to 1 UF?
Yes. Well spotted. I need more bypass caps, so let's put one of them. So this is single supply, so it just needs a single 100 nano close to its power input pin. There we go. Now we can.
Oh my god, there's so many windows open now.
Okay, so the inverted Q goes to the digital input. So this is a D flip-flop, I think is the term. There are a lot of different types of flip-flop. I think it's considered a class D, which means something. These are old parts, like the data sheets, I think, look like they're... Oh no, it's been updated. A lot of like CMOS, like CD starting part numbers, like the data sheets are... It looks like a scan of a copy of a copy, yeah. So it's I can't remember the terms for different flip flops. Oh, it is D-type, dual D-type flip flop. I can't remember all the different types of them, but this has got a D pin, which I think means like digital pin. So it's like whatever that state is, when it receives a clock, it will change the output state to being that.
Right.
So this is a trick for getting the sub-frequency. So Q's the main output, Q's, and that's the inverted output of it. So it's the inverted state sets the next data set type. So if you're just clocking it, it's going to be self flip-flopping between the two.
Right.
But then these have got dedicated set and reset pins. So set is going to immediately set the output to high, or reset would set it to low.
Right.
But we're not using the set or reset pins in this context, so those can all be grounded together.
Is that so that they don't accidentally get triggered by something?
Exactly, yeah. Or we don't need to micromanage and define it as a state. I think like that's useful for like you can use it for setting like a logic state for knowing. You send a clock and you're setting it high, and then that's it's like 1-bit data essentially. It's either 1 or 0.
Mm-hmm.
So let's go with, this will be our first sub and that will be our second sub. So it means that we want to go from this output to clock this one. And both of these are outputs. So what we can do, this is our audio source. So what I'll do is I'll draw a wire up here. Oh, we've not done this yet in this KiCad schematic. L for label. I'll call this, I'll just call it AN1 _1, just because I don't know if I can name a net the same as the name of it. It shouldn't matter, but if I keep it an underscore, then that's clean. So this schematic network is now called AN1. So if I call this AN1 as well, then if I highlight that, they are one and the same.
Cool.
I wonder if I should put I'll put a 1K resistor in line. That should be a high impedance input, so it shouldn't matter that that's connected. It's not going to affect the audio signal going further down. And if I do it before the attenuator, it means that it's the raw signal that's clocking that, so it's not going to affect the flip-flop if I attenuate that fully. It means that you can attenuate their source and bring up a sub of that while muting the source. Which is kind of cool.
And that resistor before it, is that just to stop it getting too high a signal, or?
It's current limiting. I guess like akin to I've done that in the past. I think I've had some issues in the past where if I didn't have some impedance, it would glitch. Like, there was an issue with the TSL where I got the wrong value resistor on, I think maybe the second production batch. So when you're listening to the square wave at audio rate, you'd periodically hear a stutter in it, which I didn't notice because it's not hugely immediately noticeable when you're using it as an audio source, because it's a square wave that
it's so harsh anyway.
It just adds a bit of character to it. But if you're using it in LFO ranges, then it's going to skip clocks, which that's useless as a stable clock source. So 1K seems to work here in project X. Although that is coming from a unipolar positive CMOS source, but that should be fine. I wonder if that's maybe worth replicating. So that's a bipolar signal. I've got that going into a diode. Is that going to... do I need to buffer that separately? I think it will be fine. I can check the tines, because I patched this up and tested it with the tine as the flip-flop, so I can see what it's got on its input stage if I have any full wave rectification projects. Instruō. Tine. Hardware. Proto 2. Sure. Oh, it is buffered. That is just... that's an equivalent input, so that's I think it's an OR gate. So if that's high or that's high, then that's high. So it's the button or the gate. Oh, it might be an XOR. I think I did a thing where if you XOR it, if that's high or that's high, but not if both high, then it means that whatever your clock state is controlling the on-off state, if you hold the button, it just inverts the output, so you end up with the inversion of it, which was quite cool.
If you hold the button?
Yeah, yeah. But that's gate to trigger, that's just a voltage divider and attenuator, so I could maybe change that 1K to, if I mimic that and go 100K, then that's matching the impedance of the pot itself, which is also 100K, so that should be minimal in effect. 1 meg, it's less of a voltage divider because it's such a high ratio, and it's more just a pull down. So if that's 0 volt, if that's ensures that that's pulled down to ground if that was floating, which it would never float because it could float. So that's where I've not got the normal connection. So it means that if that's disconnected, it's arguably floating, but it's pulled to ground through that. So this will always see ground as equivalent because the potentiometer is just a voltage divider. But if I'm branching it off at this node here, then if I do that as well, it just means that the flip-flop input will always be pulled down to ground, terminated at a high resistance. I think that will work. And these are 0 to 5 volts. So I mean, that worked when I tested it, and the output of these is defined by the trim pots, but they should be calibrated to 0 to 5 volts. So that's what it was patched with downstairs. I think I did have to increase, I think one of them was calibrated to like 1 volt or something like that, so I had to just rattle the trimmer on the tine a bit to get it up in amplitude, and it did sound different because it was higher amplitude square wave going into it. But these are also unipolar positive. That's probably a factor why it sounded the way it does on the patch downstairs, because if that's
The square waves that are coming out are unipolar positive?
Yeah. Well, I guess on the tine, they've got the possibility of extending beyond 5 volts. These would only ever be 5 volts because that's the power supply of this, whereas doing it with the tine, the flip-flop's not the direct source. It's switching an analog reference state, which can be anywhere from plus or minus 12. So if this is only ever going to be 5 volts, I think that's fine. It's whether or not I want to AC couple here before it goes to the normal, so that it's basically the equivalent of patching in a bipolar plus or minus 2.5 square wave versus a unipolar positive, because it's going to sum in DC here. So if this is a bipolar sawtooth wave, full amplitude 0, like plus or minus 5, if it means that every time this square wave source goes positive, it's going to be pushing it up by 5 volts. So, and if it does that twice because it's 2 flip-flops, then it's going to, it will distort by positive signal, positive amplitude saturation, just hard clipping, which maybe, I mean, it's going to be harsh square waves. It's then AC coupled here as a mixed voltage source, a mixed audio source, and then that's going through the filter. They'll just sound different. Like there's not really a right or wrong with it.
Is there an option to have that as part of the circuit that can be altered in the prototype?
Yeah. I mean, if I just add a 220 nanofarad as a AC coupling stage, then that would do the job. But I could also just bridge that, like remove that and then bridge it to being DC. So I'll do that. Do I need to have a pull down resistor? Maybe. I guess that is the pull down. I think it'll be fine. I think that value should work for AC coupling it. We'll try it, if it gets shorted, that's fine. I might just put a resistor in series as well. That could be actually, maybe these should be the other way around. So it'd be the resistor first, then the capacitors. I'll do that. So that's 1K. So this is the same as the output 1K impedance. Oh, that should be 1K. Well spotted. And then it's AC coupling that already limited signal.
Yeah.
So let's call this sub. Oops. Sub 1. Sub 2. So everything's done apart from the LEDs. Oh, that's the wrong thing. That should be a fader. Because there should be a fourth LED. Passives? No, mechanical. No, passives. Slide. Oh, those need change. That's the 30mm one. So, okay. What way round was that? Three. B100. B100. I think I might just keep them simple and just have them light, the same as the original. Because if I want them to display amplitude, I'm going to need to add more op amps and stuff, which is kind of, it's aesthetic, but it's not.
Yeah.
It's not really necessary.
I mean, no, it's not on a fader.
Yeah.
It's not, because the fader basically displays amplitude by its position.
I guess it's an indicator of, you've got the fader up for, that's displaying the level of that input channel, but then it's going to be displaying the actual resulting amplitude.
I see.
For the sake of adding a single quad op amp, we would have level indicators per one, which is kind of cool.
I mean, it would be a nice touch. Like, it would look nice, and it's another improvement on
it. Yeah.
Original.
Yeah, screw it. Let's do it. Okay. What's the best? Where did I use this exactly? The looper faders do that. I'll just check if I did it inverting or non-inverting. I'm in the completely wrong thing. Instruō, and the looper folder is still called tràigh, which was the working title of it before we called it looper.
What does tràigh mean?
I think it means something like synonymous with looping. Okay. So it was a viable name until we found loopa, which sounds like looper, and means much the same.
It's kind of it's funny that in here very few people actually say loopa. They tend to say looper.
Yeah.
Something I was wondering, so when you pass like a simple oscillator into the filter and then it easily it generates a square wave from that, what happens how does the flip-flop behave if you pass complex audio into it?
It's zero crossings that will trigger it. So any time it swings
kind of all over the place, really.
Yeah. Huh. So it'll be garbage.
Yeah.
Yeah. I mean, it might be interesting. It'll be like really. It'll be like is it fuzz distortion that does it like that?
Right.
There are certain distortion effects that are that approach where it's zero crossings, and because it's.
Yeah, it's just harshness kind of related to what you're passing.
It's an approximation of it, so it's really harsh. It's like underpowered rat distortion. It'll sound like where it's really, you can get to a point where it's almost dead, and it's the higher amplitude will get through, so you get this sort of weird gated sound.
Yeah.
So it'll be that, but without the lossiness of it. It will just be that the extreme saturated sound, which may or may not be useful. Yeah.
Yeah, I guess it depends what you're trying to achieve.
Yeah. So that seems to be how I did it. That's one fader. Is this the most recent revision? I don't know. The looper design files thing is all over the joint. Unless I moved the final production to this folder.
Pre-GitHub.
Messy. 3.5. No, this is 3.5. So this is it. This is the most recent version. I'll be able to tell because there's some modifications that were made to this section, which were. What were they? No, I don't remember. I think that's what it was. I think it was the output buffer of the output stage. Like I was pulling the. Is that there? LED. Yeah. Okay. So that's the basic circuit is non-inverting somewhere. The LED and like that. Let's do that. Could get away with a unipolar positive signal. If in doubt, simulate it just so that we know for sure it's the right approach. I mean, it's been done in the looper and it's fine, but technically I think it's bipolar op amp, so there is a every half cycle, or any the LEDs used as the half wave rectifier, so it's only positive amplitude or the negative amplitude it would be the positive amplitude that's used to drive the LED. I think technically I should have a blocking LED the opposite direction so that it's not registering the negative voltage being applied, like reverse biasing the LED, because I think LEDs don't necessarily like that, but these are low enough voltage amplitudes that it's fine.
It's not stressing them.
Yeah, but it's kind of dependent upon the LED how reliable it is. So let's go with this here.
Protect your LEDs, kids.
Safety first. Let's draw an LED.
LEDs are people too. That's actually untrue.
It's quite untrue. There's a good documentary that I watched on YouTube that was the history of the blue LED as a thing.
Right.
Because for the longest time it was considered an impossible feat.
Yeah, I remember my physics teacher at high school talking passionately about that actually.
The documentary is really good, and it does get you psyched up for it. It's like, wow,
I like
blue LEDs are the coolest thing ever.
I like really specialist documentaries like that, like the one about Helvetica.
Yeah, that's a good one.
Talking heads, multiple people speaking passionately about Helvetica.
Whoop. Okay, let's give it a signal. Let's tell this that it's a 12 volt rail op amp. And let's make this a white LED, because that's accurate. I did this exact same thing on the CSL, because there was a revision where I added an op amp per LED for the faders, because the LEDs used to be static.
Right.
I can check that as well. It will probably be the exact same thing here. Input sources, AC voltage source, one terminal. So anything positive is lighting it. If negative, I think that should be fine, because there's no... Yeah, I think it's one of these things where, like, technically I should put a protective diode opposite, so there's a path, so that negative path is... Then again, like, it's actually showing as being a negative pull when it goes negative here, versus when that's not there, it's just... There's a negative pull here, but there is no current source. I mean, this has been working. Like, the LEDs I've been using this implementation for LED driving for many years, and none of the LEDs have died. I think because it's AC signal, like it's not a constant low. I mean, like, it would never. Yeah. It's designed for audio signal, so it's not you're not saying, like, you wouldn't. I mean, you could put a DC offset to this, but it's not actually going to work. It's going to correct itself at a certain stage, but it's after the summing stage.
Hello.
Hello. We're recording, but it's long form.
Oh, don't say anything super secret.
How's
it going?
This is Mark. We just done a maths class.
How'd it go?
How you doing? Alright, I think it was okay.
Oh,
it was really good.
That's always a good sign. If you're unsure, it went well. If you're confident, it's like that was banging. Then that's where it's like.
I need to follow up with you. So yeah, this is just all Synth building stuff. This is what the sort of hub of Instruō. Yeah. Wow. This is Jason. This is like honestly.
Nice to meet you.
Nice to meet you. I seen the big modular downstairs.
Oh yeah.
Big monster.
Yeah.
And then it's like, so normally during the week there's quite a lot of people work here, so all the programmers are in there. People just
check the CSL for reference. I think it's the exact same. So if it's the exact same, I'll just roll with that. Cool. Oh no, it's different.
How you doing?
That's interesting. I didn't put it in the feedback path. I just went with.
Can you explain the difference?
So this is an non-inverting buffer, which is the same as I had before, but the difference being the diode is in the feedback path here. So let's bring that down. Let's go 100R. So it's going to be brighter whenever it. Oh wait, that didn't change it. Just 100. Get brighter. There we go. I mean that's kind of going to more of a on-off state.
Yeah.
So it's it depends on the simulation for brightness as a reference. Because LEDs vary quite dramatically. Let's go 5K. Let's go 1K. Yeah, whatever. So it's showing brightness on that. I mean, we can see the current flowing more when it's a lower resistance. If we did it this other way, where that's a locked loop, and we are kind of pulling current through the diode. Actually, I can use the same source. That way we can see them both together. And that's ground. It's the inverted polarity of it. That's, if we put this to 1K as well, I wonder if it'll display any difference. They look much the same. I think in general, this is more of a passive driving of the signal, whereas when it's in the feedback path, basically what happens with an op-amp is the output is the difference between these two. So it's the op-amp's trying to compensate, and its goal is to output the difference to try and center itself. So that's why like feedback circuitry is kind of the inverting feedback's the approach for using op-amps. Whereas here it's just buffering the signal. So we can think of this as just being a variable signal in itself. The op-amp has already corrected itself.
Right.
So it's just a static source, whereas here the LED is part of the equation, so it's involved, and it means that it's whatever the current, whatever the loss through the diode is compensated for. So this can give you much more direct and brighter results. Right. Whereas this will generally be a bit dimmer and might be, it'll be dimmer is kind of the thing. So you need to go with a lower resistor, whereas this can be a higher resistor on it. So I'll go with this. I mean, like that's what's on the looper, and it's been absolutely fine. And it's the same fader, same LEDs, so it's the exact same thing. So let's do that.
So does that mean the looper LEDs are brighter than the CSL LEDs?
It depends on the resistor value. I'll fine-tune them to get them just where I want them. Yeah. And white LEDs are very. You breathe on them and they'll light up. Like it's weird because I mean, white LEDs are just blue LEDs with an extra phosphorus like doping to the lens or something, and that makes it look white versus blue.
Right, they're filtered.
Yeah, so we wouldn't have white LEDs without blue LEDs because they are the same thing. How does that show on camera? Oh my.
Pixelate that.
I think so. Is he in the background? Oh yeah, you can see him there.
Cool.
Yeah, so white LEDs, like they're very sensitive. I mean, like you might have noticed it at times, depending on what modules you built when you were doing assembly stuff. But if a soldering iron can light a white LED, yeah, it's weird, spooky ghosts. So I'll go with this approach. I think if anyone watching this in the future has any major qualms with this, I would be interested to know what the issues are with this circuit, because it's been working for me. But I know that there's some risk of the LED being reverse powered, but I don't know what I'm doing. So the analog ICs, TL074, and that's TSOC already. So this is an op-amp entirely for visualization, which is fine. Oh, should add them all. There. And this I can move into here, put it down here. Give it another set of these. Neater. It's there, it's there, and we're going in that circuit. So let's go with I'll probably rearrange which one is where as I get into the actual PCB layout, because there will be a most efficient orientation for where these go in, because that's kind of the downside to this circuit when it's used from an op-amp, is wherever the LED is, in this case it's spread around in fixed positions with each out, cathode and anode are on either side of the fader itself. It means that I need to have two traces going to that op-amp,
right, versus,
I guess that's a benefit to this, is it's just a single signal and then ground on the other end. So it's twice the tracing. That should be fine. Can you remember what was in the looper?
Which?
In this one, the resistor violence.
I don't remember.
Where are we? 20k.
On the CSL, does the sub button change between full wave rectified and not? Is that what that does?
Does the
sub button on the CSL? What?
It's read by a microcontroller and lit by a microcontroller, and it's the GPIO from the controller that is changing switch state. So it's controlling various analog switches for routing the sub signal to the output.
Right. The effect being
you cycle through and select which. So there's the sub generators exist. It gives you sub and sub. So the original square wave source from the oscillator exists, as well as the sub, as well as the sub.
Right.
So there are three signals that then get switched between with analog switching.
Got you.
Which, if I was to do it again, I would do what I've done with the the project that must not be named yet.
It's okay, you can beep it.
Beep.
The fucker.
The fucker. That fucker. So that fucker's done differently, and I'm not using analog switches for switching them. You okay, pup? Hello. Do you want the blanket on you? You got this. You can do it. You can do it.
It's hard with the cone on, isn't it?
He's also on stacked memory foam mattresses.
So it's like the princess and the pea.
I never know what he's trying to do.
Yeah, it's difficult to interpret whether he's struggling or whether he actually likes doing that.
What's the end goal?
It's kind of inverted, its cone.
It's like he's trying to stretch out the duvet.
It's hard as well because
Are you trying to get under it?
Duvets don't exist in nature.
There we go. Well done. With an inverted cone. That's cool.
It's kind of like a turtleneck now.
Good boy. How does that look on camera now? Yeah, that's good. What a dafty. Okay, I'm completely hiding you on camera now. There we go. Cool. What were we saying?
So, well, we diverted into talking about CSL, but
the flip-flop, that's what I was saying, yeah. So the flip-flop's done differently on the CSL because I'm not using analog switches to change the state. Because they're all square wave domain, I'm using AND gates. So it means that I've got GPIO control, which in the CSL, it's controlling an analog switch that's turning on and off an audio signal path.
Right.
But I could get the same result because it's square wave domain by using an AND gate. So the sub exists, but it won't pass through unless it's happening and there's a high GPIO at the other pin of the AND gate.
I see.
Which, yeah, it's a much more efficient way of doing it. So I should revise the CSL at some point, maybe.
The CSL Efficient Edition.
Okay, what I've done there, I've just set up one circuit with the traces, moved all the other ones over there, so this is now
that a clone of that?
Yeah, but it means it's created another op-amp IC, which is U5, but only one op-amp channel of it's in existence, and then that's U6, U7, so I get rid of them. Same with the LEDs, because it's cloned them, but it means that I've got that circuitry already built, so do this. Yeah, that's it. And plus on top. Oops. There we go. Now it is actually done. That's a missing bit. I need to go to the faders and change them to being the 20mm version. That was rude. This one. Copy and paste that. Maybe.
Why were they the other version?
That's just the default that I picked as being the most common one that I used, which
I see.
Don't know if it is or not. I just guessed. There we go. That should be it.
Great. So now we
one.
just have to print that off and post it to them.
This is what people are buying as a fundraiser. I guess we do a ERC, electrical rules check, and see what. 14 errors. Error. Well, what is going on here? Why is that disconnected? That shouldn't be disconnected. But it is disconnected. Is that a mistake? Open. Error. Filter. Those should be connected. Did I just miss that, or? What is that error? Power. I don't know what that means. Okay, those are gone. Okay, so we have that. That's no connect. So there, that's where it needs the X. Otherwise, it gives you a nice big red arrow. Oh, they need to be sourced, of course. Let's go there. Which one's which? RV1A, RV2, RV3. So that's RV 1, 2, and 3 are audio inputs 1, 2, and 3. That's nice and neat. So we need to do this post fader. Yeah. Yeah, it needs to be post fader, and then before that, so it's a branch. Actually, if I make the inputs, if I double that, make them 120k as well, I think that's technically more correct. RV1. Wait, what's this? So that's RV11. So that's this one here, RV11. So that's our output LED. So I'll make that 56k. So just so it's matching the same impedance as what's going on. I don't think it makes much difference because this is going to a non-inverting input, so that's just a dead path. Because op amps theoretically draw, there's no current draw there. Like that should be the same as it just being an open circuit. But in practice, they do draw something.
So how do you select the sources coming from some other part of the diagram?
Sources coming, so like from this going from the other bit, that's with the labels.
Right, okay.
So you name the net something in particular. So label sig1. So that's RV1. Sig1. Oh. Sig2. Let's call this one 4. And then this will be
4.
Maybe some slightly different positions. Ooh. Nice and neat. Okay, move that there. Move that there. Move that there. Oop.
Oh.
There, that's there, that's there, and that's there. Cool. Run ERC. Down to 5 errors. That's good. That's weird. Why is it showing up there but not on the, not on another instance of that same bit?
Is it saying power pin is not driven by any output power pins?
I think because I never defined ground as with a power flag.
Right.
So if I do this, maybe that will, oops. Nope. Nope. Yeah. That's what I want to do. Maybe it will change it now. 4 ones, there we go. That was the issue. Ground globe. It just picked that one there randomly for whatever reason.
But actually, they were all wrong.
Yeah.
Right.
Yeah. What's going on here? That's not connected. Okay,
Close.
Should be down to 3. Oh, 2. Okay, that's easy. That's no connect. And that's power output line. Pins of type power output and power output are connected. Pins of what? Pins of type power output and power output are connected. So that means that that's a power output. Do I have this connected to the wrong side? Something? Where else is 5 volts going? It is just there. What if this doesn't need the power flag? There we go. I think I was like redefining it as a power stage. Like that's defines a power output, that defines a power input. I think putting the power flag, it kind of puts it to a different category of power regardless of input or output.
Right.
So this is already correct, it doesn't need power flags. Cool, we have
0 errors.
0 errors, that's nice. Let's do the fun part. This is our empty let's put that there for inspiration. Empty sheet. There's all our parts. So these have got to fit onto a module with all those blue lines needing, being connected. What time is it? 5 o'clock. I'll draw out the PCB outline and place the faders and stuff, and then I think that's a good stopping point. Cool. I mean, that's kind of the bulk of the process. I mean, there's process to this as well, but I might just carry on through today and time lapse record it. So what I do when I'm setting up the board is I just let's draw an actual PCB shape. So edge cuts is the layer that's used for depicting the shape of a board. Because at the moment, if I go to a 3D view, it's just components floating in space. Well, it creates like the minimum size board so that they're not just floating in space. I think that's the thing. Cool. So let's make a board. And let's set it to, I'll set it to the full dimension of the faceplate to start with, and then I'll bring it in by the margins that I would, so that the origin of 0, which is top left, is the same as that origin. Right. 0, 0. How many HP is the try? That looks like 16. Filter by legacy. $18 HP. It's wide. So 18 HP is 5.08 times 18. And then height is 128.5.
Huh.
So 3U is 128.5, and
I didn't realise you could type calculations
so
into number fields.
Yeah.
Is that standard across
I found it.
OS,
you can do it in. It's a KiCad mechanic, but it turns out you can do that in Illustrator as well.
Huh.
The thing that I don't like about Illustrator is it select something. What's going on? Why is it not showing my properties? There we go. You can do the same thing here, but they have the unit in millimeters. Mm-hmm. I don't think it matters whether you do any mathematical formula before or after the millimeters. I think you can put it before, but just.
But millimeters has to be there.
It doesn't. You don't need to type millimeters. I think you can. I think I could just type inches, and it's changed it to. It's changed it to. It's kept in millimeters because that's the unit, but it's done that conversion of millimeters to inches, which is kind of cool. Oh no, I've completely borked this now. Oh no, there we go. Whoops. Don't do that. Yeah, that's a really nice touch, especially when you're doing coordinate stuff, because you can even do rotational movements and stuff. Like so, when I'm like drawing weird positionings or like drawing concentric like rings of stuff. Although there's an extra plugin that lets you define placement based on geometry, which is pretty cool. So what I do when I'm drawing the PCB shape, I bring the top and bottom from faceplate dimensions in by 8.8. So this will be.
What's that defined by? Like, why do you bring it in by 8.8?
I think that's just a value that I measured up that fits.
Right. That's because
I think like retroactively, I think like 10 millimeters is probably the safer bet. But I've measured it up when I was designing my first module based on a dope for case. I was like 8.8 will give me plenty of movement. Everything fits. I think there were some issues. Like I had to revise the harmony at one point, which has got all the buttons along the bottom, and they were just too low for certain case manufacturers. I think tip-top cases, the lips are just a bit thicker,
right?
So it meant that the buttons would touch the bottom of the rack. So I brought them up by enough to give me full clearance, so that they were in line with the bottom of the PCB. And 8.8 worked. Like all the Instruō modules are 8.8. There's some it depends on the case manufacturing, but that's kind of it fits in a Doepfer case, and Doepfer set the standard, so I've kind of gone with, well, if it doesn't fit, it's most likely a hand-built case that's not quite on spec. Like the monster case downstairs, its rails are slightly closer, and I think that's just tolerances of. I mean, some rails and not others. Like some positions, like there's a tighter fit.
Do you know who built that case?
I don't know who built it. I think there's a full history of it online somewhere. Like there's like it's had a following, which is mad.
That's funny.
It's really strange. So let's do add 8.8, and let's do subtract 8.8, and I'll bring the outers in by a millimeter. So it's a millimeter undercut from either end. That's a safe starting point. Sometimes if it's a really dense board, I'll make sure it's in by at least like 0.2 millimeters or 0.25 millimeters, and that makes sure it
doesn't touch other modules.
Yeah. But that's not even necessarily a standard in Eurorack design. Like I think there are some modules out there where the faceplate is, matched with the PCB, which is more risky because what have I done? Because if you,
it's kind of like the Eurorack equivalent of man spreading on the train. like be considerate.
Yeah. Cool, that's there, and I'm going to hide the drawing sheet because don't need it. And I'll lock that in so that I can't even select it now, unless I tag this box, and then I can select it, but if I wanted to try and move it, it's going to give me a locked item, which is just quite nice for knowing that things are in the place it should be. So let's put this.
You've not shifted the entire basis of it.
Yep. And this I will hide those, and then I can use these coordinates as my reference point. And I'll change over to an actual mouse because the sizes are there. So this is our output jack, which is this guy. This is a feature I really like of KiCad, is if I select a grouping of stuff, so say I want to pull together that op amp and all the passives around it, it's going to include the faders because they're in there. I jump over to the board.
They're selected there.
Yeah, they're selected there. If I hit P, I can't remember what that stands for. I think it's something for like placement, for like it just pulls them all together into a new grouping. So immediately they're all grouped in one place, which is pretty handy.
Yeah.
So let's go here, E. So this is that by that.
So how are you managing to put that? Is it center point that you're placing it by?
Yeah,
right.
yeah.
Okay.
And the origin of this jack is that pink center point. So
Cool.
That's exactly in that location.
And did you make this jack?
Yes, I redrew it based on the same equivalent that I use in Eagle.
Right.
Yeah. Which what's going on? Oh, that's annoying. This has got. Oh no, that's fine. It does give me a XY coordinate. Yeah, like a lot of the parts I've either pulled, like I copied a version of this that was in one of the hardware libraries. Quite a few of them I did that. A lot of the ICs I redrew them and just mimicked the exact same silkscreen ledger that I used to have in the Eagle, like the pots, like that. Just that outline shape. I drew that years ago in Eagle, and that was the drawing for the pot that I've used since.
Right.
And it's very different from what's a way to do it? If I add potentiometer, then 9mm. Alpha there. That would fit the same type of pot, but I don't know. I don't like the shape. I mean, that's got tinned oval-shaped holes for the mounting, whereas I've found a non-plated through-hole mounting hole that fits both types well, and I think specifically for the tall trimmers, like they've got a bigger thing. Like these, you have to force them in so it kind of like snaps in and holds, but doesn't need soldered, but it's got the rigidity that it needs for feeling the way I want it through a faceplate. So a lot of it's just been stuff that I've found through trial and error.
Yeah. So you, when you say you found that, you mean that size of hole?
Yeah.
Using that size of hole.
I made a footprint and fabricated a board, and I was like, okay, if it's too loose or it's not quite big enough, and then like a next revision of a board, I did that. So a lot of it is just referencing a design that I tried before and worked. Okay, so this is where I need to be careful with which orientation they're at. Let's open tràigh. Okay, so it's for all four, it's the 4 pins at the top. So rotate that. And match these. I like this as well, that KiCad, if I copy and paste from here, I can select all and it pulls that as well. It just ignores the text. Whereas in Eagle, if I try and do the same, it needs to be a number.
It's like this is invalid.
Yeah. I wonder what happens if I do... Yeah. It seems to convert the unit to inches. So that's that 331.979 inches.
So it's not just ignoring it, it's actually reading it.
Yeah. KiCad's good. Changing to KiCad was a good idea. Okay, course pot. That is...
This podcast is sponsored by KiCad.
Yeah. So. And fine pot. What's it there? I mean, there are probably better ways of doing this where if you've got a reference, there'll be a way to export coordinates as a CSV file.
Just kind of process it.
Yeah, but stuff like this, I figured it only needs done once, and then it's done in the project. So, yeah, I definitely don't work like a programmer a lot of the time because I don't
automate stuff.
Yeah, there've been times where I have put in the work and automated a process, but
you can get really lost in that as well, though.
Yeah, it's like working with Obsidian, where you're just constantly perfecting the way to curate an Obsidian vault and never actually use it for note taking.
Yes, and making YouTube videos about that.
That's the pot. That's that one. I guess that's kind of part of Eurorack in general. It's like a system is never done. You're always anticipating the next module purchase, which it's good and bad. I mean, it keeps us in a job, so that's fine. But
I suppose if you wanted to rein that in a bit as a user, you could start using rivets instead of screws.
And that's the pot, that's a resonance pot. which is there. And input faders. Let's do jacks first. So input 1. I guess I am assuming that these are in the right position. There have been so many times where I've got something wrong between, a lot of the times I'll start with the layout in what would have been Eagle and just placing the footprints around to try and get the spacing, and then translate that over to Illustrator to draw full graphics on it. But if I get something off slightly and then draw the graphics, there have been times where I've ordered the faceplate and it's come and it's the wrong, there's a hole in the wrong place, so the faceplate doesn't fit. I still do that. I did that with the first Glock prototype. Anyway, it was the toggle switch hole that was at the bottom right somewhere. It was lower than it should have been, but because the toggle switch is horizontal movement, I was able to just like mount it in and just bend it down. So I mean the toggle was just leaning slightly down, but it fit.
Usable.
This fader. What I might actually do at this stage, once I've got the components placed, is I've got footprint parts that are mounting holes that are like draw the right edge cut dimension based on an origin for the faders and stuff like that. So if I put them into the schematic, pull them over, I can then just like align them immediately with everything, like move them over by like 150 millimeters or something like that, and then I can have the skeletal outline of the faceplate just as a reference. But when it comes time to drawing the actual faceplate, I've already got that there. I can just copy and paste into a new file.
So does the faceplate get done in a separate file from the board file?
What I'm starting to do is do it all in the same project. The only downside is if I go to the 3D view, whatever settings I've got for the green solder mask being the standard, I tend to keep it green solder mask just because visually in the 3D render it's a bit clearer to see. But the faceplate, I'll draw the render and change the solder mask. But if I've got two PCBs in an Eagle in a KiCad project, I don't think there's a way to set the solder mask for this versus the other one. So. But I can like keep them contained, and it's easy to and it means I'm referencing the exact positions of the components on this board. Just move them over, and then that's the outline. So I'm not like having to do this whole translation again. Oops. That's them. That seems like a bigger gap. I think that's wrong. I think it's 16 HP, not 18.
Yeah.
I think so. Is that wrong on the website? That's funny. Yeah, 81.28. Yeah, that's wrong. Fun.
Wonder what it says on modular grid.
So it means this will be 5.08 times 16, and then that minus 1. There we go. Yeah, that looks better.
Modular grid's got it right.
Cool. Just our own website. It's a legacy module. Maybe I should just, for this redo, just add 2 HP. Just
to make it right.
Yeah. That's there. Oh, these need rotated 180. It's all good. Render looks good. Cool. Just need to cram all this stuff onto here. What I'm also going to do on this revision is do what I've done more recently and put the trim pots around the big knob, and then that way there's no trim pot sticking out the back. It's all hidden by the knob itself. Yeah. Which, doing that is much easier to do now that I'm using KiCad, because I can actually place things and see how it looks.
Oh right, you mean in the render?
Yeah, so I've got I was quite precise with the drawing courtyards for bits, but the 3D models are, I think, quite accurate to life. Put this down. That way the actual trimmer parts are as close in as possible, so that they're well under the bottom of the pot. That's good. If we were wee enough, we could just stand right there. Whee. Oh, that's the biggest you can make them. Cool. So I'll probably reorient them around it depending on where the circuitry is, so that I've got as efficient as a path as I can.
Efficient pathing for stuff, is that for the satisfaction? Because surely
in this case, more satisfaction. I think for something that's all analog, I'd need to really go out my way to draw paths as obtusely as possible to make them detrimental. Yeah. It matters a lot more when it's mixed signal designs, where there's digital components and peripherals that are communicating at megahertz rate for, SPI bus, data transfer, like things like that. Any of those data lines, certain practices that you shouldn't do. You shouldn't have like there should be a full copper ground plane underneath, but specifically without any breaks going with the traces running over it. Like if you had like a big break, like a trace running on the bottom side that split the ground plane, and the data lines are on top of that, that's a no-no, because it can add, it basically turns the PCB itself into a capacitor and stuff. Like there's different rules. I mean, it depends on the type of signal, how good or bad it can be. I think a lot of them, it's a lot more robust than it leads on to be. Like there's the spec that the data sheets will quote will be advising on the best practices for that. I mean, the first board that I laid out that used, the first module I designed was the Nebulae, which had a USB line on it from where was it used? Yeah, it was USB port that was like through connected onto the Raspberry Pi that was mounted on the back. I didn't know about matched signal tracing or like matched length differential pairs, so like I had my data positive and data minus just going all over the place, and it worked fine. And that's apparently a big no-no. You're meant to have the same length and like running with like a specific distance apart, like this a specific trace thickness, and no breaks in the ground plane underneath, whereas mine were just doing what they were doing with breaks all over the place. So, but it works fine. So it means that USB 2 is actually quite robust. But then again, like we had an issue with the unnamed project where the USB port is capable of high speed, full speed. High speed is faster than full speed. I think it's the other way around from what it sounds. And I think I misread a data sheet somewhere, or like copied over, like just historically when I've had USB lines from a microcontroller to the USB port. A lot of the times you'll see like a 10 ohm to 33 ohm resistor in series on those lines.
Right.
So I just put them in, like just on autopilot, and seems like all the STM chips, like looking at the Nucleo boards, there are no resistors in line with them. So putting those in meant that the full speed wasn't actually working. Like high speed, full speed was working, high speed wasn't.
Right.
And we need the high speed for the remote, for the USB UF2 bootloader flashing thing. So fortunately it does work when I remove those resistors, because that we're kind of relying upon that for being able to update firmware over USB. So that's good.
Yeah, that's good.
What we'll do is add the mounting holes. So I'll do this on a sheet that's just for reference. Face plate.
In about 5-10 minutes, I need to pop out for
cool.
maybe 15-20 to do a complicated car swap situation with Jess.
Mounting hole. I guess I'm just waiting for a message from Emma. And like, when are you coming home? I think she's doing stuff. Oh no, I have a missed call. Oh no, that was this morning.
So are you just pushing your luck just now?
I don't know. I might just crack on and. It's already 5:30. I should probably call it after I've placed these. So these are the faceplate mounting holes. Panel mount. So that's a 3.3 millimeter diameter plated hole,
which is just for aesthetic that it's plated, right?
It's electrical as well, so I'll connect all these to ground.
Oh, right, okay.
Same with any of the jacks, so it means that any of these, that's the sleeve, so invariably that's ground. So it means that the back of the faceplate is a full copper plane.
Cool.
And those electrically connect through all that. These are metal chassis of the pots, but they're just floating. They just happen to be made of metal.
Right. So
I've never grounded them, but I think it's an option. But I tend to go with a non-plated through hole for the pots. Faders are just rectangular holes, but all the jacks I electrically connect to the ground.
I guess they've all got caps on them as well.
Yeah. Okay, so that's these four. So what I'll do is set them to being 7.5 by 3. This will be 16 HP, so 5.08 times 16, and that minus 7.5. Nope. 5.08 times 16, so that's the HP minus 7.5, and then Y is, I didn't put Y in, there we are, that's there.
So if you didn't ground those, would you have the potential of getting a buzz off them?
Possible. I think this is a vagueness in the spec. Bastel used to, I think they still do, you can get wooden panels, so wood's non-conductive, or acrylic panels, so there are panel materials that are non-conductive.
Yeah.
Even anodized aluminium is, the anodized layer is non-conductive. So aluminium is very conductive, but not when it's got, the anodized finish acts as an an insulator.
Right.
So a lot of panels. I mean, the good practice is to like use that as an actual grounding source, so that there's common ground across the whole thing. But it's less relied upon than I think it used to be traditional, or for like.
It's like a best practice that's been abandoned by some folk.
Yeah.
I guess.
Let's be 7.5, 125.5, and so 16 times 5.08 minus 7.5 by 125.5. There we go. So our mounting holes floating in space. Actually, what I will do is...
Did you create another sheet for these?
Yeah, I just put them in because this way, when I'm in the main sheet, I can just highlight this, and then everything's highlighted at once. And I can do Shift M for move that to the right by 100 millimeters, and then my faceplate will be exactly 100 millimeters moved over from it. So if I do this as a second PCB faceplate, 16 times 5.08 by 128.5. What I do actually, for the faceplates, actually nudge them over by 0.1 in every direction, just so it's undercut slightly on all edges. Just find it fits a bit better.
Okay.
Case to case. I've always done this and it seems to work fine. So it'll be 0.1, it'll be 28.4. And if I move that over by 100, there's our faceplate next to that.
Cool.
So more stuff to add in. There are 1, 2, 3, 4 pots, and just copy that. Mounting holes. Where's this? It'll be in, I think these are in my folder. Yeah. Hole jack. Nope, not jack. Hole metal shaft pot. That's it. These don't need to be connected to anything because they are just non-plated. And bring them in. This is a fun, I don't know if this will necessarily work. So that's, I've got key commands set up for using command and page up, page down for a line horizontally and a line vertically. But I think what it does is it pulls it to the center of this.
The real center.
The real center. Yeah, I don't know how to change that, which is unfortunate. But I think it should. If I just like drag it over, it should. Let's try other layer. There we go. If I'm viewing the top layer, then it'll snap to grid on the actual origin, which is handy.
Cool. And then you just shift them all by...
Yeah, so just move that, highlight that, move by 100.
Nice.
Same with these. This will be a mounting hole that's... did I make these? Sleeping with his eyes open again. Hole, fader, 20 millimeters. There's 4 of them. This one, because the outside, the courtyard is perfectly squared on the center, this should work with the key commands to center it. So it's just things that the actual shape is not fully centered on the origin. One, two, three, four, five.
He's a big dreamer. You having fun?
Are you bored? I'm doing this for you, quite literally. Is that in the center? Yes. It's weird, it picks out other centers with the snap to, so I tend to go through and just double check the X and Y's fit. 1, 2, 3, 4. Oh, I missed one. Missed one. Good, looks good, looks good, looks good, looks good. Oh, grumble, grumble. Done. So now we have our skeletal faceplate. I'll need to add holes for that. That's easily done.
Cool.
Cool. That's a good point to call it for the day. Try again, get status, add, get commit, on to PCB, get push. Done.
Perfect.
Perfect. You had a lazy day, pup. Okay, so that's day one down, and the faceplate panels laid out, and the hardware's placed out on the main board. So next up, it's going to be finding the most ergonomic placement of all the circuitry around this. So I'm going to try and get all the actual components topside, so that the bottom will be as blank as I can get it. Then I can fill it with pictures and stuff. Yeah, skeletal faceplate. Yeah, and then I need to actually do that, route it, and then I'm going to revise the faceplate itself and feature this guy on it somewhere. It's okay, it's only 10 more days of the cone.